It's a new week, so let's stuff it full of science. My name's Dan, it's time to go exploring for a brand new Fun Kids Science Weekly. Thank you for popping along on this adventure to discover so many of the science secrets lurking through the solar system. This week, we'll learn why planets refuse to have corners. We uncover why they aren't cubes, blobs, or triangles, but smooth spinning spheres.
So a good example of this at a much smaller scale for us is rolling Play-Doh between your hands. So the pressure you get from applying the pressure towards the Play-Doh from rolling it around into a ball is equivalent of what gravity is doing to a planet.
And we reveal how smarter manufacturing and eco-friendly materials might be the key to a greener future.
People are starting to use artificial intelligence or AI to design new materials so that things like batteries or electric cars or even solar cells are functioning much more efficiently.
Plus, our dangerous Dan is one deadly beast that's pretending to be another. It's all on the way in a brand new Fun Kids Science Weekly. And we'll start with your science in the news. NASA will put a nuclear reactor on the moon by 2030. That's what news channels over in America are saying. It's part of US ambitions to build a permanent base for humans on the moon. And if people want to live there, well, they'll need energy, and a nuclear reactor is a way of getting that done. It sounds like an exciting idea, but some people are asking questions of how this can be done so quickly in 5 years when money is being taken away from NASA. Also, some people are worried that we're focusing too much on what's happening across space when we should be trying to solve problems happening down here on planet Earth. Also, a volcano in Russia has erupted for the first time in 500 years. The Krasheninnikov volcano in the far east of Russia near Japan threw up an ash plume almost 4 miles into the sky. The emergency team in Russia said there are no threats to nearby towns and that it might be connected to a large earthquake in Russia, which last week led to tsunami warnings all around the Pacific Ocean. The last recorded eruption of this volcano was in the 15th century. It lies in the Pacific Ring of Fire, which is an area that takes in so many different islands and countries with a high number of earthquakes and volcanoes. For the first time, erupting in 500 years. It's very mind-blowing how that's just a tiny amount of its life, and this stuff just happens in science all around us. And our final story this week, a mission is underway to rescue the world's most beautiful snail. Polymeter tree snails are disappearing from their home in Cuba because, well, their colourful shells are so stunning, collectors want to keep them. Biologists in Cuba have teamed up with specialists from the University of Nottingham to try and save the snail. Professor Angus Davinson is one of those specialists and joins us now. Angus, thank you so much for being there. When was the first time you heard of this problem with the polymeter tree snail?
Well, yeah, quite a long time ago, but it's taken many, many years to actually become involved in the project to try to save them. So more than 20 years ago.
So I've mentioned that they are beautiful. I've seen photos. They're so gorgeous and stunningly colourful. Just tell us a little bit about this tree snail. What makes them so unique and why do people want them?
They are stunningly kind of colourful. It's not just that you might have a very beautiful red snail. You'll have beautiful red snails, orange snails, green snails. What colours haven't I mentioned yet? Not blue, but just about every other colour you can imagine. And then lots of patterns on top of that. So almost, you can say, I think almost every snail shell you would look at is different. And so whilst we do have, whilst there are colourful snails in lots of parts of the world, I think these ones are kind of the top of the tree in terms of the most colourful, most beautiful snails. And they do live in trees as well, so they're tree snails.
And what's the problem? Why are we losing so many in Cuba?
Yeah, so there's multiple problems. They're only found in a quite limited distribution in eastern Cuba in the first place, so that's kind of an issue. Climate change is affecting their ability to live in some of those places. Deforestation, so loss of forests, is causing a problem. But then on top of all of that, because the shells are so beautiful, people are prepared to pay good money for the shells, which of course involves collecting and then killing the snails to do so. That's not legal in Cuba, and it's not legal to export them, but it's still happening. And so the real money, if they're illegally exported to another country, you can sell the shells for quite a lot of money.
So you've teamed up with biologists over in eastern Cuba. There's a team from the University of Nottingham who are trying to save the snail. What's the grand plan? How are you going to go about this?
Well, I think part of the grand plan is to alert people as to how special these snails are, and to be aware that they, for example, should not be buying shells. And I would say that's not just these colourful polymeter snails, but if you're on holiday, maybe at a beach resort, and you see shells for sale, think twice about where they've come from, because they probably haven't come from somewhere locally, and they might have come from a forest, and they might be endangered. So these polymeter snails are absolutely special, but it reflects a much wider problem.
Now, we've mentioned how beautiful these animals do look, and it's never nice for a species to pretty much become extinct, especially at the hands of us humans. But when we focus on trying to save different animals, it's because of what they are doing to maybe the local ecosystem or the food that they're helping bring to our plate. Why do we want to save this tree snail? Is it simply because they look so stunning? Is there any more reasons because of how they work in their local ecosystem?
Yes, I mean, they are stunning. So in that sense, as a biologist, I would say we should try to preserve as much diversity in general as possible. But of course, these are stunning, so maybe they're special in that sense. But no, of course, so one of the explanations as to why they're so colourful is probably because birds eat them, they predate upon them. And so there's a whole bunch of animals eating them, which are reliant upon the snails. And then on top of that, the snails are breaking down, they're eating leaves, they're eating things that grow on leaves, so they're part of the whole ecosystem in terms of recycling nutrients.
When we have big conservation projects like this, how long is it before we might hopefully start to see a boost in the numbers?
Oh gosh, that's a really difficult question. And what you're saying there is so difficult to do. I couldn't put a timeline on that, but what I would say is, I think especially when we get good press like this, it puts pressure puts pressure on local authorities to maintain the forest. If you ever got a chance to go to eastern Cuba, in my view, they could form an important part of like an ecotourism thing, where you're using the snails to bring money into the local economy at the same time as conserving them. That would be an amazing outcome.
Well, it's really good to try and be part of the momentum. It's been amazing to chat to you, Professor Angus Davinson. Thank you for joining us.
You're welcome.
Thank you very much to Angus for coming on the show, telling us all about the stunning snails and why they're threatened by their own beauty. Now, it's time for questions. If you have anything sciencey that you want answered on the show, make sure you leave it as a voice note for me. You can do that on the free Fun Kids app. You can do it at funkidslive.com. I'd love to have you starring on the podcast. You can ask the question. Make sure you send it over, and then I will get a genius to answer it for you. What have we got this week? Here's one sent in as a message from Barney. Hey, Barney, who wants to know, how is carbon made? Carbon, a very important element. It's found all over the world, quite often in the air. It makes carbon dioxide. That traps the sun's heat. Also, carbon has been squashed down over years and years and years, and it makes diamonds. Now, if there was no carbon, well, you couldn't breathe, because plants need carbon dioxide. They make oxygen, so if there's no carbon, there's no carbon dioxide, so there's no oxygen. Also, it's trapping in the sun's heat, so without it, it would escape and the oceans would be very cold, frozen solid. Carbon can be made in stars. The nearest one to us is the sun. It's a process called nuclear fusion, where with the sun, with the huge pressure and the heat on there, it turns one element into another. So that's how we can make carbon. And a lot of the carbon was made at the start of the universe. It's found its way here on Earth, which is always being recycled in the air and which we're still digging up from underground. It's such an important element, Barney. Thanks for letting us chat about it. Let's get on another question. This is a voice note sent in by Atlas. What do you have?
Hi, my name is Atlas. My question is, why are planets round-shaped?
Atlas, thank you so much for your question. Why are planets round? Shall we find out? Rebecca Warrilow is from UCL and is an expert on all things space, flying in the sky. Rebecca, thank you so much for being there. So, why are planets round?
Yeah, that's a great question from Atlas. So the short answer is that planets are round because of gravity. And gravity is a force that pulls everything towards the center of an object. And it's actually the same force that keeps us standing on Earth. So in space, when something gets big enough, gravity starts pulling equally from all points on the surface towards the center. And the shape where that force is equal in every direction is a sphere. So that's why planets and moons and even some big asteroids are round or spherical. So a good example of this at a much smaller scale for us is rolling Play-Doh between your hands. So the pressure you get from applying the pressure towards the Play-Doh from rolling it around into a ball is equivalent of what gravity is doing to a planet. It's just at a much larger scale for planets. And instead of our hands, it is the force of gravity. And a planet has to be big enough for gravity to be strong enough to pull it into a sphere in the first place. So for planets like Earth and Mars, which are rocky, they usually have to be, I think it's about 600 kilometers wide. So that means that our moon is actually big enough to be affected by this force as well. So that's also round. But if something is smaller than that, like Mars's 2 tiny moons, the gravity is no way near strong enough. So they end up more kind of potato-shaped. And not all planets are actually perfectly round. So most of them spin around the sun. And that's what causes us to have a day. And that spinning motion actually causes them to bulge at their equator. So the middle part of the planet is slightly wider than it is tall. So planets are slightly squished, actually. And Saturn is the most squished planet in our solar system, whereas Mercury and Venus spin more slowly. So they're actually almost perfect spheres. So hopefully that answers your question.
Oh, it does, from Atlas. So why does something spinning on its axis mean it slightly squashes and squeezes towards the middle? Why does it bulge? Do we know?
Yeah, so as something spins, if you're imagining a ball where it's wider at the kind of middle, so that part is actually spinning a lot faster than it would be at the top of the ball. So as it's spinning through space at a faster speed, it kind of pushes everything out towards the middle of the planet, which is why it bulges.
Now, I know that you're a planetary geomorphologist. And,
yes, that's right.
Which is an amazing job title. And you've done a lot of work looking at Mars. So just to build on Atlas's question, anything unusual about the way Mars looks? Is it a perfect sphere? Is it bulging? Is it rocky? What do we know?
Mars is the last terrestrial or rocky planet in the inner solar system. It's about half the size of Earth, and its day is about the same length. So it takes about 24-ish hours to spin around. So Mars is strange because it actually has the tallest mountain or volcano in our solar system, which is Olympus Mons. And it also has a huge crater on it as well, which you could fit Mount Everest in and still be looking down on it. So Mars has pretty extreme topography all over the surface for being such a small planet.
Well, it's been great to talk about Mars, and to answer your question, Atlas, that's why planets are round. Rebecca Warrilow, thank you for joining us.
Thank you.
If you have anything sciencey on the podcast that you'd love answered next week, make sure you leave it as a voice note for us on the free Fun Kids app and at funkidslive.com. If you came to see our Fun Kids Science Weekly live show in Nottingham last weekend, I hope you really enjoyed it. We had fire, we had deadly beasts, we explored the universe. And we're doing it all over again. Throughout summer, we're taking Fun Kids Science Weekly on tour. It's an amazing live show with genius guests, with secrets from the solar system, dangerous Dans, loads of experiments that you can do at home. We discover how to make a lightsaber. You can hold something from outer space. So it's all going on, and we've got a few shows left this year. I'd love to see you there. You can say hello, you can even touch the meteorite as well, that's all right. Get a grown-up, you can find out more and get your tickets at funkidslive.com/tour. Now for this week's Dangerous Dan, where we learn about some of the most weird, unique and deadly things in the universe, we're headed to the Middle East, to Iran, to learn about one deadly beast that pretends to be another. Let's talk about the spider-tailed horned viper. We've only properly known about it for the last 20 years. It's a sandy brown colour with blotchy, darker patterns that help it blend into the rocks around the desert that it slithers through. It's got horn scales all over its body, which make it look a bit like a dragon. It's venomous too, biting with a toxin that destroys its prey, rips apart the tissue there, and causes internal bleeding. The truly remarkable part of this creature is its tail has these long, thin strands that flick out of it. Together, they look like a spider, and that's how it's deadly. This snake will hide in the rock. It will flick its tail out, shaking the strands. A passing bird overhead thinks it's a spider. It's lucked out. There is some food. So it swoops down to strike, and that's when the snake springs into action, whipping back its spider-looking tail and launching with a lightning-fast bite, filling the bird with venom and getting its own meal too. It's a devastatingly cunning creature, using mimicry to fool other beasts into coming close before ambushing its prey in an amazing way. Not just spider-looking tails, it's got dragon-looking horns all over, and that's why the spider-tailed horned viper goes straight onto our Dangerous Dan list. For this week's Battle of the Sciences, we are looking at what you use every day and how that might be changing in the future. We're trying to discover the greatest science in the history of the world. This week, it's materials and manufacturing science with Neil Rath from the University of Warwick, who joined us. Neil, thank you for being there. You have 1 minute to tell us why the science of materials and manufacturing is the best of all. That minute starts in 3, 2, 1, go!
Thank you very much. So hello everybody. My name is Neil, and my area of science is materials and manufacturing. So this means I look at products like footballs, shopping trolleys, bicycles, and even cars, and decide what is the best materials to use and what's the best way to make them. So this is very much linked to being environmentally friendly. So for example, for cars, we can choose the lightest materials, metals or plastics, so that when the car drives around, it doesn't weigh too much and doesn't emit too much CO2 or use too much electricity. And another interesting thing that we work on these days is what happens at the end of the life. How do we take products apart so that they don't end up in the rubbish tip, that we can take them and make new products out of them?
Well, there we go. Neil, thank you so much for your pitch as to why it's the best science. So, materials and manufacturing. Right now, because of the focus on the climate crisis and our waste and how much we can pollute the planet around us, how much work is there going on to invent new materials, to not just work with what we've got, but to make brand new stuff that might be better for our planet than what we have now?
Oh, you're absolutely right. There is a lot of work out there right now. So, for example, people are starting to use artificial intelligence or AI to design new materials, so that things like batteries or electric cars or even solar cells are functioning much more efficiently. So companies like Google have artificial intelligence programs to explore creating materials which don't actually exist in nature to do that.
So before AI was helping us out with this, how on earth would you scientists come up with something new? I mean, we have the materials around us. We have wood, we have plastic, we have, cardboard, paper. How on earth were you using science to invent a brand new material?
So what we did before AI was take different bits of materials that already existed and try and put them together to get the best of both. And we usually call this composite material. Probably one which most people know is carbon fiber, which we take some plastic and these carbon fibers and put them together to get the best of both materials.
So that's thinking about like the big picture of saving the planet. What smaller problems are scientists like you that work in your field helping to fix with materials and manufacturing?
So it's always trying to improve little bits which are already existing. So something which material scientists are starting to use a lot is something called life cycle analysis, which is a computer program which looks a bit like Scratch programming if your users use it, which you look at an existing factory, for example, and maybe one box tells you what is the impact of melting steel and pouring it into a mold. The other box might tell you what's the environmental impact of using your product. And so you can take things that already exist and completely understand what is the environmental impact, and then go back and try and change it a little bit. Maybe try to use more renewable energy or make it more efficient that way.
Now, what is it? There are so many different sciences out there that an expert like yourself could kind of learn about and turn their hand to. What is it about materials and manufacturing that you really enjoy?
Well, I think because you can do absolutely any product in the world. You can look at computer chips, gaming consoles, scooters, even stuff like cardboard boxes, and look at what the material is and decide if it's good or bad for the environment, and explore exciting new ways to use these materials.
Now, Neil, we always finish our chats in exactly the same way. Let me throw you forward years and years towards the end of your career in the science. What's one question that you would like to know? What's a problem that you want to solve?
I think whether we will have 100% renewable energy in many, many years' time. Because it's still developing, and it will be interesting to find out if we'll ever actually get there.
Wow. It's so far, it's one of those ones that we'd love to wait and see. Materials and manufacturing. Is that the greatest science ever? We'll thank Neil Rath for telling us all about it. Thanks, Neil.
Well, thank you very much for having me.
Thank you very much to Neil Rath for telling us all about sustainable materials and manufacturing, the science behind that. We can learn more now checking in with Amy Aviation. You might have heard some of these episodes in our Fun Kids Science mid-weekly specials that we've got going on at the moment. Amy knows all about planes. This week, her and Zach, they're diving into the sustainable side of aviation for when the aircraft is in service and after they retire, from smart new materials and greener fuels to recycling and reusing.
Amy Aviation, reaching for the sky.
Hi, Amy Aviation here. Today, Zach and I are landing in a very different kind of adventure. Because we're not taking off, we're getting down to Earth, talking about how aviation can play its part to reduce environmental impacts on the planet. That's right, we're flying into sustainability.
And decarbonisation.
Sustainability? Decarbonisation? What do all these big words mean? Well, right now, planes create about 2.5% of global carbon emissions. So engineers and scientists are on a mission to build smarter, more efficient aircraft that have less impact on our environment. So where do we start?
Fuels of the future!
Let's talk power. For many years, planes have used aviation fuel, which is a carefully refined, light petroleum that can withstand extreme temperatures. More recently, there have been developments with sustainable aviation fuels that aren't made from fossil fuels, but things like algae and biomass, and even used cooking oil.
I guess batteries can also help.
Correct. It's likely in the near future, small electric planes will be common for flights up to 500 miles. But you need small, relatively lightweight batteries with a lot of power, ideally sustainably sourced. There's also another fuel in the mix, and that's hydrogen. Instead of belching out CO2, hydrogen-powered planes would only leave behind water vapour. Cool, right? Airbus, one of the world's biggest aircraft manufacturers, is developing its Zero-E project, looking at building planes using hydrogen fuel cells instead of jet fuel.
So future planes will be more sustainable. But does it end there?
Magic materials.
No, the stuff planes are made from is changing. Smart new designs means we're building planes with sustainability in mind. That's making materials easier to trace, repair and recycle. Heavy metals are being swapped for lightweight, super strong new materials. And fancy new plastics called thermoplastics that are strong, light and easy to recycle might be used for the airframes. Even biofibres from things like algae are being turned into aircraft parts. Plane manufacturers are working hard to make sure parts of a plane can be built using materials that can be reused instead of wasted. That way, when planes retire, they can be taken apart and turned into something new. And the job doesn't stop once an aircraft touches down for the last time. That's when we can start reusing and recycling all those materials.
Recycling planes? You'll need an enormous recycling bin for that.
It's definitely a challenge. With about 15,000 aircraft retiring over the next 2 decades, we need to find smart, eco-friendly ways to say goodbye to our flying friends. And that's where special aircraft recycling centres come into play. Old planes are being carefully decommissioned. First up, any useful parts are removed. Things like engines, landing gear and electronics. They're inspected, fixed and then sold on to fly again.
So it's like a plane parts spa day. You'll come out as good as new.
That's right. And by reusing parts instead of buying new ones, we're saving money and the planet. Once all the parts are out, the aircraft can be taken apart piece by piece. Everything from the hydraulic systems to the fuselage.
Fuselage? Sounds like a fancy pasta.
It's the main body of the aircraft. Most aircraft bodies are made of aluminium, steel and titanium. And guess what? They can all be recycled. In fact, over 90% of an aircraft's weight can be reused or recycled. And even fittings like seats and windows can be repurposed for cool furniture for our homes. And even used to make shoes. That's all thanks to specialists like dismantlers, recyclers and maintenance crews who work together to make sure nothing goes to waste.
It's the ultimate team-up. Avengers, disassemble.
We also need to remember, it's not just planes. Airports can also be more sustainable by using renewable energy for airport operations, whether powering terminals or ground equipment like electric airplane tugs and baggage loaders. It's all part of reduce, reuse and recycle, aviation style, and it's not just for the environment, it saves money too. Next time you see a plane soaring overhead, just think, one day you might be wearing part of it.
Amy Aviation. Reaching for the Sky. Created with support from a CAA Reach for the Sky Challenge grant. Find out more at funkidslive.com/Amy.
There is more from Amy Aviation in the next Fun Kids Science Midweekly, which is on the way in a few days' time. You can also listen whenever you like. Give her a search. We've got brilliant podcast series for you. Wherever you're listening to this, it's on Google, Spotify, Apple, on the free Fun Kids app and at funkidslive.com too. If you have a question, make sure you send it as a voice note to me on our app and website. And if you want to come and see Fun Kids Science Weekly live, make sure you get your ticket at funkidslive.com/tour. I will see you next week. Fun Kids are our children's radio station from across the UK. You can listen around the country on your app, on our website, and if you've got a smart speaker, wake it up and ask it to play Fun Kids.